In all honesty, if you have the equation, you already know what it is anyway. Okay, so before we get to these, let me talk about this. You want to have these in your nose. What are those three types of equations right there? Can you see those? Or is
that divided by or?
It's not very good.
So it won't be a trinomial? Is that what you're talking about?
No, what type of equation are each one of these? Like, what will they graph to be?
Oh.
Okay. So let's think about that. Those three over there on the right. Zoom in on those if you can.
Yeah.
Okay. Those three on the right. What are they graphing to be? Like they're a standard equation for what? Let's start with the bottom one because that's the one we've been working on the most. What's the bottom one called? This one right here. That's a bx. Sorry, that's hard to see that. Bx, like that, plus c. Ax squared plus bx plus c. What's the bottom one? What do we call it? Quadratic equation. It will graph to be a what? This is what we call a quadratic. And it will graph to be a what? Parabola. Okay? And what do we call the one above that? We had those all last year. A line. Yep. It's to the first power. That's the only one with an x in it. So this is called a linear equation. And it will graph to be a line. Those are both easy. You had this other one last year a little bit also. You should have. I don't know. He does some weird stuff and does geometry. So I don't know if you guys get into these or not. Did you do those? The top value? What's it called? What type of equation is it? Say what?
Parabolic?
No, it's not. Parabolic is the bottom one because it's to the second power. I guess if your b was to the second power, that would be a parabolic. You see what I mean? But usually this isn't going to be to that. What's this one going to be? This is called an exponential equation. Okay, exponential equation, and this will have what we call an exponential curve. Okay? All right. Do you understand exponential equations and how they work? Yes, no, maybe so? Let's do one really quite easily and quickly. That's an easy one to do. You may have seen this, maybe not. If not, you'll see it eventually. Anybody ever seen that equation? The amount of money on an account that is gaining interest continually is going to be P e to the RT. What does the R represent? Rate. And what does T represent? Time. And what does P represent? Principal. And A equals the what? Amount. Okay? The E is actually a constant. It's on your calculator. It's the e to the x key. And the way that works, you might want to record me now for a second, is this way. So if I had a marble sitting on this table and I want it to reach my foot, what's the fastest way to get that marble? I know the only force acting upon it is going to be gravity, so I'm just going to barely let it go off, right? I'm going to hold it on the edge of the thing and then just drop it. Only thing acting on it is gravity. How am I going to get it from there to my foot? What can I do? I could have a straight board, right, that takes it down that way. I could put a board there. Will that be as fast as if I have some sort of curve thing there, though? If I have a curve that goes down and then out to my foot, will that help make it go faster? Yeah, because gravity is acting on it. So I want as much gravity to act on it as I want. Well, I could just let it drop straight to the ground, but will it ever reach my foot? No, I'd have to have some sort of curve, right? So this curve that goes to my foot that would create the most speed, not just a straight board, but a curve that would cause that is called the exponential. It's e to the x. It's the fastest and strongest curve known to man. If you ever were going to race, I used to have them in Cub Scouts and that, what were they called? The cars that they raced. Pinewood Derby cars. If you were going to have a Pinewood Derby car, then the Pinewood Derby car would go the fastest if you could actually have a perfect curve, right? Has anything to do with, if every car weighs the same, the fastest any of those cars will go, no matter how you build them or whatever, would always be if you had a better track that was causing gravity to act on it better, right? And so that's one way to think about it. The Golden Gate Bridge, it's called a suspension bridge. So it has very few pillars. It only has 2 pillars and it crosses this big, huge waterway. Well, how can that bridge stay up with only 2 pillars? They use cables, and what curvature do those cables have? The e to the x curve, the exponential curve, okay? And it's the same way that we actually calculate continuous interest. So think about it. If I say that it's only gaining interest every year, then we only calculate that once a year. Every month, only once a month. That's a different equation than this one. This is calculating interest every moment of every day of every second. Okay? So let's say this. Let's say that we wanted to buy a car, okay? And we're buying the car for $10,000. Okay? And the interest rate that we're going to pay for this car is 3.5%. How do I write that as a decimal? 3.5%. How do I write it as a decimal? 0.035. And t is really this key exponent that's causing the exponential to happen. But let's say we wanted to pay that car off in 5 years. How much would the actual cost of the car be? Did you really pay $10,000 for it? You paid a lot more than $10,000 for it. How do you find it? Do it on your calculator. Somebody got a calculator? Got the calculator? Put in the 10,000. Then you'll hit the e to the x key. Make sure that goes in parentheses. So you're going to have 0.035 times 5 close parenthesis. This will be the total amount you're going to pay for the car. And you're going to be like, why would anybody do that? Why didn't they just give the guy $10,000 cash? Well, they didn't have $10,000, obviously. So what did you get on that? 10,000 e to the 0.035 times 5, close parenthesis. And then tell me what you get. So you should have 10,000, then hit the second e to the x key, whatever that is.
$11,912.4621.
$11,912 point what?
46.
46. That's how much it's going to cost you to buy that $10,000 car. You paid almost a fifth as much in interest, right? Because 1/5 of the 10,000 would be about 2,000. You're paying about $2,000 more over. And by the what time that car is paid off, is it worth $12,000 that you paid for it? It's worth maybe 5 now after 5 years. You see what I mean? It basically is going to go down in half of what it was worth. But people do this. Why do they do this? Well, because they only care about the monthly payment. So if I divide this by how many months is in 5 years, by the way? 60. Divide it by 60. And this is all most people care about. How much is their monthly payment?
$198.
I can afford $200 a month. That's going to be their payment. Okay? So we do these all the time, these exponential graphs. What happens is as more time goes, what's going to happen to how much money you pay for the car? It's going to go exponentially higher, a lot higher. Let me give you another example. This one I probably shouldn't give in class, but just don't tell anybody. Of course, it's going to be on YouTube, so a lot of good that's going to do me. All right, so gambling in Vegas. Okay, you're picking. Team A is playing Team B. Team B is playing. Or sorry, Team C is playing Team D, and E is playing Team F. Okay, you have to pick the winner of each game. Now they do these like point spreads, you know. So like, for example, if Emory's playing South Sevier, no, they wouldn't bet on a high school game, but if Emory was playing South Sevier and Emory was at home, they'd be like, oh, no, Emory's going to win that by at least 20 points. So they're going to say, all right, if Emory wins by 20, you win the bet. If Emory wins the game, but it's only by less than 20, you would what? Lose the bet. So that tries to make it so that it's an equal opportunity either side to win or lose the bet, right? So how many ways could you pick those 3 games if everything was equal? How many different combinations would you have? So let's pick a team. Pick a team on this one. Pick one, anybody.
A, B.
I want to, well, one of them's got to win. So I'm going to pick what? A. Let's say I picked A. Then I could pick what?
D.
And then I could pick,
E.
okay, now just change the last one. A, D, I also could choose what? F. Now let's change the middle one. So I could have AC what?
E.
E and AC F. Correct? Everybody with me? Now could you do that same exact thing for B?
Yeah.
Change all the A's with B's. How many ways can I pick them then? Can I pick 3 games? How many different ways? No, 4 and then another what? 4 picking the B team, right? I could pick it 8 different ways. So what's your chances of winning if you were to bet 3 teams? B, D, E, right? B, D, F, B, C, E, and B, C, F. Sorry, keep doing my E's and F's wrong. Okay, so if I was to pick it in a game, if the casino was saying, all right, you got to pick 3 winners in 3 different games, and I'm going to pay you 6-1 on your money. That's what they pay you. Meaning that if you win all 3 games and your picks, you're going to win $6 for every dollar you bet. Sounds pretty good, huh? Guess what the problem is? What are the chances of you actually winning, though? It's not 1 in 6, it's 1 in what? Where did the other $2 go? 8 people bet it, right? Let's say 8 of your friends, and you're saying, we're going to get this covered. We're going to bet this all 8 different ways, right? Each of you put $1 down, so how many dollars have you bet? $8. And one of you wins what? $6 on your $1 bet. So they win $6. Where did the other $2 go? The casino. That's how the casinos make money. You never will. You may win that one bet once in a while, but the rest of the time, the only way to win gambling is to own the casino, right? Because otherwise, you might win that one time, but there's 8 different possibilities here. And they're only paying you 6-1, so they're keeping $2 out of every $8 bet. That's how casinos make money, obviously. Okay? And the one guy that won the $6 is like, sweet, I won $6, I only had to bet $1. But it's not that easy, right? Because there's 8 different possibilities. Well, this is called exponential also. How many ways can this game be picked? Just this one game. How many ways? 2. How many ways can this game be picked?
2.
And how many ways can this game be picked?
2.
What should I do with those 3 numbers?
Add them.
No, if I add them, I only get what? 6. I really should what?
Multiply.
Multiply them. It's 2 to the 3rd because you're picking how many games?
3.
3 games. See how it's an exponential? What if I picked a 4th game? What would my chances be? It's going to be times by what? 2. So 8 times 2 is 16 different ways it would increase. And they're going to say, well, if you bet 4 games, I'm going to pay you 12-1 on your money. And you're like, sweet. I only have to bet $1, pick 4 games, right? And I win $12? But really, what's the chances of you winning that? 1 out of 16 different ways. So for every 1 winner, there's 15 losers. You see what I mean? That's how they make money. So, anyways, this is how exponential functions work. It multiplies by the same value over and over and over again. Everybody got it? Okay, so even if you weren't taught that too much last year, hopefully you got that now. Okay, let's check every one of these and see if they're one of the other. Now, you're going to have to write some of this in your notes, by the way. Write these 3 in your notes, because this is going to be key. All right? Let's see what happens here. Looks kind of weird, huh? As we go here. So let's think about differences. What's the difference between negative 10 and negative 4? What's the difference between those two? It's 6. I'm going to put negative 6, but yeah, it's 6. Okay? What's the difference between negative 2 and negative? Because I'm just following the number line, right? So between negative 2 and negative 4, it would be what? What's the difference between those two numbers? Negative 2. Again, we're just going negative direction, right? Okay, between negative 2 and 4, now we're going the other way. We're going a positive direction from that. Okay, we're going in positive direction from that. So now I would have to what? Add 2. I'm probably going the wrong way there. Sorry. This is 6, 4, sorry. And this is, or 2, sorry, my bad. 2 and negative 2, sorry. Because from negative 2 to negative 4 is negative 2. That was my fault. I just went the wrong way. Okay, from negative 4 to negative 10, how far is it? Think about a number line again. Negative what? 6. Sorry, I just did that opposite of what I should have been doing. Those numbers don't have any relationship to each other at all, do they? You're like, why did we even do that? Because that doesn't mean anything. But watch the second differences. This is where it gets interesting. How far is it from 6 to negative 2? In which direction? Think about 6 on a number line going to negative 2. Negative 4, right? Is that true? Think about 6 on a number line going to negative 2. Or sorry, going to 2. Now what would you do to get there? Subtract what? 4. How do I go from 2 to negative 2? Subtract 4. Say, oh. And then from negative 2 to negative 6, what do? Subtract 4. This is called common second differences. You want to write that in your notes. If y values of a function have common second differences, we know the function is a what? What do you think that would graph to be? Think about just the numbers in here. Think about the negative 10, negative 4, negative 2, negative 4, negative 10. What do you notice? With the negative 10s and the negative 4s. What do you think it's going to be? Exactly what? Like remember when we played the game of war? Right? It's going to be symmetrical, isn't it? So if it's symmetrical, which one of these is it? Is it quadratic? Is it linear? Is it exponential? Yeah.
Can you say that again?
Yeah, second differences. Okay? If the second differences are all the same, okay, of the y values, if the second differences of the y values are all the same, it must be a what? Now I'm asking you. Which one of those is it? It's a quadratic. Yeah, this is a quadratic. And you'll notice that these kind of repeat sometimes up in there. They don't always have to repeat, by the way, because it may be just on one side of the quadratic that it's giving you. You with me? Just on the upside. I did it that way because it's the easiest way to show it. Okay? But you'll still check the second differences. Okay? And if the second differences are true, it's a quadratic. Okay? Let's look at this one. Okay? Let's see what this one is. I'm going from 15 to 21. How would I get there? On a number line. Add 6. Then I would what? 21 to 27. Add 6. 27 to 33. Add what? 6 every time. These are called the what differences then? First differences, if these were called second differences, right? These are called what? First differences. If the first differences are all exactly the same, what type of a graph is it giving us? Out of those three, what do you think?
Linear.
Linear, yeah. In fact, the slope is up what? Up 6 and over 1, because you're going from 1 to 2, 2 to 3. You see what I'm saying? That's really just a slope. And so if the first differences are the same, it's linear. Okay? Those are the easy ways to check. Now, let me show you something that would be kind of interesting. If I did first differences on this one, would it work? Are they the same? 6, 2, negative 2, negative 6. No, they're not the same, are they? So there's no way I would say that this was what? Linear. Everybody with me on that? Okay. here's the key part. Let's try this one down here. What if we did first differences on this one? What would we get? From 2 to 6. 2 to 6 is what? 4, 6 to 18, 12, and 18 to 54. Somebody help me on that. 54 minus 18.
36.
36. Now let's do second differences because it obviously isn't what? It's not linear, right? It's obviously not the first differences that work. Let's try second differences. 4 to 12. How do I get there? 8. 12 to 36. Oh, heck. Second differences didn't work. Is it quadratic? No. So if you try the first differences, it doesn't work. It's not linear. If you try the second differences, it doesn't work. It's not what? Quadratic. The next thing you want to check is the ratios. So this one is done by ratio. Okay? The ratios take the second divided by the first and the third divided by the second. Now, by the way, it can be any two consecutives. It doesn't matter. You're going to get equivalent ratios. Okay, what I mean by that is I'm going to take 6, that was the second, divided by the first, 2, and I'm going to compare that to the third, 18, divided by the second, 6. I also could take 54 divided by what? 18. Well, what's 6 divided by 2? What's 6 divided into 18? 3. What's 18 divided into 54? You may not know this, but guess what it is? 3. If the ratios are the same, if they have a common ratio, we know that, meaning that you did second divided by first, third divided by second, fourth divided, that's what common ratio means, by the way. The ratio between any two consecutive values should all be the same. Now, what if they're not consecutive? Then it wouldn't work, right? So you have to make sure they're consecutive. But that's how these work. If those are all the same, then it's what? This is exponential. Because really, I'm multiplying by what every time? 3. Multiplying by 3. Multiplying by 3. That's called exponential. Sorry, I didn't finish the word there. Exponential. Okay? That's all there is to it. I'm now going to give you the worksheet. I'm going to go through a few of them with you on the worksheet. You can cut that off now.